Hello everyone, welcome to prevent a solution given this nice exponential equation, which is actually 4 to the power of x plus 1, subtract 4 to the power of x, subtract 1, this is equal to 24. So what is the value of x? Now before we dive into the solution, if it is your first time you come across my videos, please like this video and subscribe, okay, so that you can get notified when I upload new videos. Now solution here, x plus 1, we can express x plus 1, okay, basically as x subtract 1 plus 2, okay. So let's substitute this. Now we'll have 4 to the power of x subtract 1 plus 2, subtract 4 to the power of x subtract 1, this is equal to 24. Now 4 to the power of x minus 1 plus 2, this is basically in the form of a to the power. So we are saying that 4 raised to power x minus 1 plus 2, this is in the form of a to the power of n plus m, which we can express as a to the power of n times a to the power of m. Let's apply this property. So we'll have 4 to the power of x subtract 1 multiplied by 4 to the power of 2, subtract 4 to the power of x subtract 1, okay? This is equal to 24. Now here we'll have 4 to the power of x subtract 1, okay? You can see this is common here. So we factor out 4 to the power of x minus 1. Into the bracket we'll have 4 to the power of 2 subtract 1. This is equal to 24. Now we'll have 4 to the power of x minus 1 multiplied by 4 squared. This is 16 subtract 1. This is equal to 24. Now, we'll have 4 to the power of x subtract 1 multiplied by 16 minus 1. This is basically equal to 15. This is equal to 24. Divide both signs by 15. So that now we'll have 4 to the power of x subtract 1. This is equal to 24 divided by 15 here. We can divide here by 3. This is 8. By 3 here, this is 5. So here we have 8 divided by 5. So now to solve for the value of x, we introduce the natural logarithm on both sides. So we'll have log 4 to the power of x subtract 1. This is equal to log 8 divided by 5. Now log 4 to the power of x minus 1. This is in the form of log a raised to power n, which you can express as n log a. Let's apply this property. So we'll have x, that is log 4 to power x minus 1 becomes x minus 1 log 4. This is equal to log 8 divided by 5, okay? So that we divide both sides by log 4, okay? So let's proceed here. We have x subtract 1. This is equal to log 8 divided by 5 divided by log 4. Now, log 8 divided by 5, this is in the form of log a divided by b, which we can express as log a subtract log b. So let's apply this property. Here we'll have x subtract 1. This is equal to log 8 divided by log 4 subtract log 5 divided by log 4. Now here we have x subtract 1. This is log 8 divided by log 4 subtract log 5 divided by log 4. We can express 8 basically as 2 to the power of 3, and we can express 4 basically as 2 to the power of 2, okay? So here we'll have x subtract 1. This is equal to log 2 to the power of 3 divided by log 4, which is actually 2 to the power of 2, subtract log 5 divided by log 4, which is actually log 2 to the power of 2. Now, applying the power rule property, we find that log 2 to the power of 3 becomes 3 log 2 divided by log 2 to the power of 2. This is 2 log 2 subtract log 5 divided by log 2 to the power of 2. This becomes 2 log 2. Okay. Now let's simplify here. Log 2 and log 2 simplifies so that we'll have x minus 1. This is 3 over 2. Subtract log 5 divided by log 2, which is basically in the form of log a divided by log b, which we can express as log a to base b. Applying this property, we'll have log 5 to base 2. Now the next step here is we take negative 1 on the right hand side so that x is equal to 3 over 2 subtract half log 5 to base 2 plus 1. Okay, so here we'll have x is equal to 3 over 2. This is 3 divided by 2 plus 1. Okay, so the LCM here, this is 2. 2 divided by 2, this is 1. 1 times 3, this is 3. Plus 2 divided by 1, 2 times 1, 2. So this is 5 over 2. So we'll have 5 divided by 2, subtract half, okay, log 5 to base 2, okay. And now since a half is common, we can express x as half into the brackets. This is 5, subtract log 5 to base 2. And this is the value of x. This is the value of x. Okay, so let's verify that this value of x actually satisfies the equation. Let's verify. Now let's verify that the value of x, which is a half into the bracket 5 subtract log 5 to base 2, actually satisfies the equation. Now, if you recall, we end 4 to the power of x plus 1, subtract 4 to the power of x minus 1. This should give us a value of 24. Now, let's substitute the value of x. Now, x can be written as 5 subtract log 5 to base 2 divided by 2 plus 1. 1 is a whole number, so this is over 1. Subtract 4 to the power of x, which is again 5 subtract log 5 to base 2. This is divided by 2. Subtract 1. 1 is a whole number, so this is over 1. This should give us a value of 24. Now, from what we have here, this is the same thing as 4 to the power of, okay? So here, we have the LCM here as 2. So this is 2 divided by 2, which is 1 times 5 minus log 5 to base 2 plus 2. Then subtract 4 to the power of 5, subtract log 5 to base 2, okay? This is actually subtract 2 divided by 2. This should give us a value of 24, okay? So from here, we'll have 4 to the power of 5 plus 2. This is 7. Subtract log 5 to base 2 divided by 2. Subtract 4 to the power of 5. Subtract 2. And this is 3. Okay. Subtract log 5 to base 2. Okay. All this divided by 2. This should give us a value of 24. Now, we can express 4 as 2 to the power of 2 to the power of 2. Okay. So this is 2 to the power 2 multiplied by, this is 7 subtract log 5 to base 2 divided by 2. Subtract 4 again, which is 2 to the power of 2 multiplied by, into the parentheses, this is 3 subtract log 5 to base 2 divided by 2. This should give us a value of 24. Now let's simplify here. We simplify here so that we'll have 2 to the power of 7 subtract log 5 to base 2 minus 2 to the power of 3 subtract log 5 to base 2. This should give us a value of 24. Now, from what we have here, we find that 2 to the power of 7 minus log 5 to base 2, this is in the form of a to the power of n minus m, which you can express as a to the power of n divided by a to the power of m. Now, this will be 2 to the power of 7 divided by 2 to the power of log 5 to base 2, subtract 2 to the power of 3 divided by 2 to the power of log 5 to base 2. This should give us a value of 24. Now, 2 to the power of 7, this is basically equal to 128. Okay? And 2 to the power of log 5 to base 2, this is actually in the form of m to the power of log a to base m, which you can express as basically a. Now, 2 to the power of log 5 to base 2, that is log 5 to base 2, this is actually equal to 5. Okay? So let's substitute this. 2 to the power of 7 is 128, so we'll have 128 divided by 5. Subtract 2 to the power of 3. 2 to the power of 3, this is equal to 8. Let's substitute 8. So this will be 8 divided by 5. This should give us a value of 24. Now, we have the LCM here as 5. So 5 divided by 5, this is 1 times 128. So this is 128. Okay? Subtract 5 divided by 5 again is 1 times 8. This is 8. This is equal to 128 subtract 8. This is 120 divided by 5. So if you simplify here, this is basically equal to 24. And that means that the left hand side we have 24, which is equal to the right hand side, which is 24. So that means that the left hand side is equal to the right hand side. And what does that mean? That means that the value of x, which is basically a half 5 subtract log 5 to base 2, actually satisfies the equation. So kindly follow the steps, like this video, and more importantly, subscribe. This will help me a lot, my good people. See you in the next video. Bye bye.